Welcome to another coding tutorial, and in today's video I'm going to show you how to create this sparkly magic wand. I want to make this sparkly magic wand to bring in a little extra magic to the new year. And Happy New Year everyone, this is the first coding tutorial of 2025. So without further ado, let's get started. We're going to start by creating a star. And how we're going to create a star is actually using this function called quadratic vertex. But before we get there, let's just draw a point using a function vertex. So I'm going to put in the function called vertex, which is a built-in function, and you need to provide two arguments, the x and y coordinates of the point that you want to draw. So let's say that we want to draw a point at width divided by 2 and height divided by 2. So at the middle, in the middle of the sketch, I click run and you don't see anything, and that is because to use the vertex function, you need to put in two other functions, begin shape and end shape. Click run, and you still don't see anything because usually you need to put 2 points. So let's do, how about vertex of 100 by 100. And by providing two vertex points, vertices, it basically just connect these 2 points together to create a line. And if we were to do one more, how about 150 and 100? Now you get 3 points, but as you can see, there are only 2 lines that connects the 3 points. And if you want all the 3 lines to connect all of the vertex points, all you need to do is provide the word close inside end shape. And then now you have all the 3 lines. But what we want to do is what I want to do first is translate the origin point from the top left corner of the canvas here to the middle. Let's translate it by width divided by 2 and height divided by 2. So now the origin point is in the middle of the canvas, if I spell this correctly. All right, and then what we can do is I'm actually going to delete these 2 points and provide the argument 0, 0. And with the argument close inside end shape here, you can actually see a point. But now what we're going to do is that we're going to use a function called quadratic vertex that I mentioned earlier. So quadratic vertex is a function that adds a quadratic Bezier curve segment to a custom shape. To help you understand how it works, let's come to an example here. How we're going to do it is that we're basically going to provide 3 points. The 2 points are the points that we want to create a curve in between, and then the third point is going to be a control point. So think of it as you can see here, think of it as a point that basically pull out the line that connects the 2 other points. And how we're going to use it is that we already have begin shape, we have vertex, and we have end shape. And now we just need the function quadratic vertex and provide 2 additional x and y coordinates. And how this works is that the control points here, the red one, is going to be inside the first and the second argument of the quadratic vertex. And then the 2 points that you want to use as the anchor point is going to be the third and the fourth argument of the quadratic vertex, or the point inside the vertex function. So how we're going to create a star is that we're going to have a total of 4 anchor points, top, right, bottom, and left. And then the control point will actually just be the origin at 0, 0. So let's do the top and the right point first. So we have vertex here, but instead of 0, 0, it has to be 0, a certain scale size. So let's do -100. All right, so we have one up top here. And then now we're going to put in quadratic vertex. And then our control point is 0, 0, right? And then our point to the right is going to be 100, 0. Ta-da! So now we have 2 points that is being pulled by this control point at 0, 0. So now we're going to continue using the quadratic vertex function. The first point is now going to be the point here. So 100, 0. And then the second point will have to be 0, 100, right? We want the bottom point. And then the control point is still the same at 0, 0. All right, we're getting somewhere. So now let's do the next one, which is going to be 0, 0, -100, and then 0. And then the very last point is going to be this point here, right? So 0, 0, comma, 0, comma, -100. And ta-da! We have a star. And instead of using a hard-coded number of 100 here, I'm actually going to create a variable called size. And we're going to set it to 100. And you can change the size to whatever you want, right? Let's say 10. Ooh. Oh, here. All right, but I'm going to keep it at 100 for now. So the next thing that I want to do is I want to give it an ability to rotate. And we just need a function called rotate. And how about we rotate by, let's do pi/3. So this is just to show you that we can rotate the stars, because when we create a star object, I want to randomize the starting rotation of each of the star objects. Perfect. So before we move forward, I actually want to play around with how this looks a little bit. As you can see from the beginning sketch, that each of the star objects actually has this glowing yellow effect. And you can do it using a system variable called drawing context that provides direct access to Sketch's canvas element. It provides many specialized features that aren't included in the p5.js library, and it provides access to these features by exposing the Sketch's canvas rendering context to the object. And if you come down to the examples here, you can style some shapes using shadow, which is exactly what we're going to do. But in the second example, you can actually style the circle or whatever shape you have using a color gradient. So actually, I'm going to copy and paste the way that they do the shadow effect here. And let's just click run. All right, so now we actually do have this black shadow color at the back of this star. So how about we play around with the color first? I'm actually going to change the color from black to yellow. All right, how about we also change the background color to black? Okay, and then the blurring effect here, drawing context dot shadow blur, what if we do 0? All right, so you can see that it is crispy clear here, right? So if we do, how about 20? So the higher the number, the blurrier it is, which makes sense. And then if you look at this, shadow offset Y and shadow offset X, what if we put it at -50 and 50 here, just to see what it is doing. So you can see that it is basically offsetting the shadow, right? So I'm actually going to keep it at 5 and -5, and let's do the blurring effect at 10. Perfect. So that is how I'm going to do the star. Actually, last thing, I don't want the stroke, so let's do no stroke. All right, so that's our star, and I'm going to put it inside a class. So let's come to this arrow here, click the plus sign, click create file. I'm going to call this file star.js, and then before we write the class, let's reference the file, go to index.html, and then come to this line of code, copy and paste, change the name to the name of your file, in my case star.js, and now we are ready. We're going to start with the word class. I'm going to call this class star, and then I'm going to write a constructor function and also a method called display. And if we go back, we basically want to copy this whole entire thing. Then size will be part of the constructor function. All right, so inside display, we're just pasting this whole thing, and we're gonna start by changing width divided by 2 and height divided by 2 here, and put it as this.position.x and then this.position.y. Then that's going to be our first variable inside here, position. And it is going to be a vector, and a vector is an object that can hold 2 to 3 values, and we're going to use it to hold 2 values, the x and y coordinate of where we want the center of the star to be, and we're going to use a method called createVector to create a vector at x and y location. and x and y is going to be the parameters inside the constructor function. For rotate, I'm going to put in another variable called this.rot. This.rot is going to be a random angle between 0 and 2 pi. And if you want to randomize any values between 0 and something, you don't need to put in 0. You can just put in whatever that max value is going to be. And then what else do we need? Oh, we need to put in two important functions, push and pop. Every time we work with the transformation functions, in this case, translate and rotate, we need to think about whether we want to use push and pop. And push basically saves the transformation, and pop returns it back to the default value. In this case, where the origin point is at the top left corner of the canvas, and then the rotation is at 0. And we want to use push and pop so that every time we create a new star object, it starts at that default value before it calls translate and rotate here. The last thing that we need to not forget is the size, right? So let's do a random value also between, how about 1 and 10? And do not forget to change size here to be this.size. All right, I think we're ready to create some star objects. So let's go back. All right, so I'm going to start by creating an array called stars. And then instead of just creating a bunch of stars inside setup or draw, I'm going to actually make it interactive by using a function called mousePressed. And this function is called every time you press the mouse. So I'm going to, every time you press the mouse, add a new star object inside the stars array. And you can do that using a method inside an array class called push. And all we need to do is put in the name of the array and then dot push. And then we're basically pushing in a new star object, right? Where? At mouse X and mouse Y location. And then before we do anything, we need to also make sure that we display all of the stars that we create. So I'm going to loop, use a for loop to loop between I equals to 0 to I less than stars dot length. And the length of the star will change over time, right? As you press the mouse. And we're gonna call stars of I dot display. Run, press, 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 press. Ta-da! So now you have some static stars every time you press the mouse. All right, so before we create some movement for the stars, how about I change from mousePressed to mouseDragged? And so this way, you can actually create a bunch of stars when you drag your mouse. Perfect. All right, so to create some movement for the stars, we need to work with some velocity and acceleration. I'm going to create two additional variables here, vectors, velocity vector, and I'm going to start it at 0, 0. And then for acceleration, let's do the same thing. Let's start it at 0, 0. And then I'm going to create another method called update. And basically, to move things around, we need to update the position with the change in position, which is velocity. And then we need to update the velocity with the change in velocity, which is acceleration. And we can do that by using a method inside the vector class called add to add the two vectors together. So first, we actually want to update the velocity vector first. So we just do velocity.add, and we're just adding the acceleration vector. And then after that, we update the position by adding it with this dot velocity vector. And you might have guessed, actually first we need to call the update function, right? So stars of I dot update. That right now it's not moving, and that is because our velocity and acceleration vectors have values of 0, 0. So how about we change the y value of the velocity vector to 1? And then now our stars are moving downwards at a constant speed of 1 pixel, right? But what we can also do is, how about we change the acceleration to, if we do 1. So basically here, the acceleration is constant at 0,1, but velocity is basically being updated, right? So it's being added with this 1 every time the draw loop is called. So the velocity or the speed is gonna increase very, very fast. And you can see that from here. So this is also how we usually work with gravity when we do any type of these physical simulations. And that looks pretty cool. All right, so let me show you one thing. So if we come back here and I print out stars.length, just to see what is the length of this stars array. And you can see it is at 105 right now, but there are actually no stars on the sketch. And as I drag more, then the length of the stars increase. But you can see that when the stars are actually no longer on the sketch, the length of the stars remain the same. So it's okay with a fewer number of stars, but as you run the sketch longer and longer, it is just going to slow down your program. So what we want to do is that we want to create a conditional statement. In this case, we could say like, if the y value of the position is greater than height of the sketch, then you remove it from the array. But another way that we can do it is that we can actually create a variable inside the constructor function here. Let's call it life, and I'm going to set it at 255. And then inside display here, we're going to use it as the transparency, which is the second value inside the fill function. So let's do 255 and then this dot live. And then inside update, we're going to update this by decrementing it by, let's do 5 at a time. And then I'm actually going to put this at 0,0. All right, so as you can see here, the transparency goes to 0 over time. And then now the conditional statement that I want to write is actually, let's put it inside a new method called finished. We're going to say that if this dot life is less than 0, then this dot done equals to true. And this dot done is another variable that we're going to create that starts with false. So when life is less than 0, then that star is done. And then once it's done, first, before we go back to sketch, inside update here, we need to call the finished method here, right? And how you call a method inside its own class, you just need to put in this dot and then the name of the method. So this dot finished. And now inside sketch, what we want to do is inside this for loop here, we're going to say that if stars of I dot done is true, right? Then we want to remove it from the array. And we can do that using a method inside the array class called splice. So stars dot splice. And splice can take in arguments in a few different ways, but the way that we're going to put in is we're going to provide 2 arguments. The first one is going to be the index of an object that we want to remove, which is I, right, when it's done. And then the second argument is from that index, how many objects do we want to remove? And we only want to remove that particular one, so we just put 1. And then if I click run, and then as you can see, it goes back to 0. Ta-da! Perfect. But we're not done with how we do this yet, because even though you don't actually see anything wrong visually with how it comes up on the sketch here, but we don't actually want to call the for loop in this way because of how splice works. Let's say that we have a total of 5 star objects. Let's say that index equals to 0 is fine, index equals to 1 is fine, but then once index equals to 2, that particular star object is done. So we use a splice function and then we remove that object. And how it works is that all the objects that to the right of that particular object gets moved to the left. And so now we're already at I equals to 2, right? So the next time that we go to the for loop, we go to I equals to 3, which means that object number 4 never gets checked. And so basically we're going to skip some objects every time that we remove something from the array. And so how we can fix this is actually quite easy. So instead of looping it forward from I equals 0 to the length of the array minus 1, we just loop it backwards. So we need to start with I equals to stars dot length minus 1. Then if I is greater than or equals to 0, then we decrement it. And by looping it backwards, we solve the issues of an object being skipped. And if I click run, it still works. All right, so I'm gonna delete this print. What we want to do next is we actually want to give it a little bit of some randomization. So what I'm gonna do is I'm going to create a variable called rand, and rand is gonna be a Boolean variable that returns either true or false. And I'm gonna set it equals to random. So this random function returns a value between 0 and 1, right? Not including 1. And I'm gonna do random greater than 0.5. So it is going to basically be true 50% of the time and then false 50% of the time. And once we have this inside update here, what I wanna say is if this.rand is true, right? Then I want to set acceleration to be equals to a random vector. And we can do that using a method called p5.vector.random2d. And this returns a random vector. And we're going to start this at 0, 0. So 50% of the time, we're going to get some randomization. So let's try it. All right. And if this is too much, then we can actually multiply the magnitude. So this basically gives us a vector with random direction, but with the same magnitude. So we can do dot mult, and we multiply it by a different magnitude. So how about we do 0.05? So it's very small. All right. The last piece that I want to do is that I want to create like an explosion every time you press the mouse, as you can see from the beginning. And to do that, I need to tweak the code a little bit first. So we're gonna, instead of putting in 0, 0 here, we're gonna do vx and vy, set these as the parameter. And then let's go back to sketch here. So now this has to be 0, 0. All right, now we're gonna write another function, right? Let's call it mousePressed, right? So this is basically what we did previously. It is going to be called every time you press the mouse. And we want to create an explosion of a random number of stars. So how about we create a random value between, let's do 20 and 50. And then we're going to use a for loop that goes through I equals to 0 to I less than num, I plus plus. And then now we want to create a random vector. Let's call it velocity. And to do a random vector, we do it the same way, p5.vector.random2d. And then now we're going to push these random number of stars inside the stars array. So new star. And we want it at the mouse x and mouse y location as well. But then we're going to put in velocity, this vector, right? Velocity.x and velocity.y. And as I mentioned earlier, that this basically gives you a random direction, vector direction, but it is at the same magnitude. And you can see how that affects this. This has to be y. It basically makes this circle shape of an explosion, even though there's some randomness based on the acceleration that we did through the random value we did earlier, right? But how about we actually multiply this vector by a random magnitude. Let's do random between, how about 2 and 5. Ta-da! And there you go. This is my take on a sparkly, magical wand. So I hope that you enjoyed this one. I have a bunch of tutorials that does something similar to this, so I put all the resources in the description, and I hope that you give it a try.